Hello everyone, welcome to my channel. This time around we are looking at reflection of light from plane surfaces. As we all know that when light strikes a surface, it is either absorbed, transmitted or reflected. When a light is thrown back to where it is coming from a surface, this is known as reflection. And we have two types of reflection. We have regular reflections, which occur when light strikes a smooth surface, and scattered reflection, which occur when light strikes a rough surface, for example, a page of a book. Now, if you look at the diagram here, you can quickly describe what reflection is all about. The light that strikes the surface is known as incident ray, which can be represented with capital letter I, and the one that is thrown back from the surface is known as reflected ray, which is represented with capital letter R. And there are some other terms used in describing reflection. We have a line that is perpendicular to a reflecting surface, which is known as normal, represented with capital letter N. And also, the angle between the incident ray and this normal is known as the angle of incidence. It is represented with small letter I, while the angle between the normal and the reflected ray is known as the angle of reflection. And lastly, from the diagram, we have angle represented with small letter d. And this shows the angle between the reflected ray and the original parts of the light through the mirror. Let's quickly consider the loss of reflection before we come back to these angles. Now, from the loss of reflection, the first loss is the incident ray, the reflected ray, and the normal at the point of incidence all lies in the same plane. As we can see from here, the incident ray, the reflected ray, and the normal at the point of incidence, they all lie on the same plane. Also, the second law of reflection states that the angle of incidence is equal to the angle of reflection. Let's come back to this place. Now, when we have a regular reflection, it is observed that this angle of incidence is always equal to angle of reflection. Now, from there, they may ask us to calculate angle of deviation, which is a small letter d, and mathematically, we all know that the angle between the original parts of the ray that is striking the surface and the part it will follow without reflection, the angle is on a straight line, which is equal to 180 mathematically. And if that is the case, according to second law of reflection, we have I equal to R. So considering that, we can quickly derive equation for angle of deviation D. That is, if the three of them are on a straight line, D will be equal to 180 minus the sum of I and R. And as long as I and R, if they are equal to each other, we can have this equation here. In case you are asked to calculate the angle of deviation for a ray striking a plane surface, you can make use of this formula. Okay, now moving away from this, let's quickly consider one example using the second law of reflection. The question here says a ray of light strikes a plane mirror at a glazing angle of 55 degrees. We have to determine the angle between the incident ray and the reflected ray. What is glazing angle? This is the angle between the incident or reflected ray and the plane mirror. Let's quickly go back to that diagram and I will quickly show you what glazing angle is. That is the angle between the incident ray and the mirror, or the angle between the reflected ray and the mirror. That is what is known as a glazing angle. Now, and if this is given as 55 and the angle between the normal and the reflecting surface is equal to 90, definitely we are going to have our incident angle to be equal to 35 degrees. And if incident angle equal to angle of reflection according to second law of reflection, we are going to have this equation here, that is our I equal to our R equal to 35 degree. And the angle between incident ray and reflected ray will be equal to 35 plus 35, which is equal to 70. That is the angle between here and here will be equal to 35 plus 35, and that will be equal to 70. Okay, let's move on by considering the properties of image formed by a plane mirror. We are using plane mirror here because plane mirror is a perfect reflecting surface. It has a perfect reflecting surface. Now, when ray of light falls on plane mirror, the image is formed through a process known as reflection. And this image form have the following properties. Now, the image formed by a plane mirror has the same size as the size of object. That is, it will have equal size as the size of object. Also, the image formed by a plane mirror appears to be at the same distance behind the mirror as the object at the front of the mirror. And also, the image formed by plane mirror is laterally inverted. That is, it is reversed back to front. For example, if you are standing in front of a plane mirror, if you stretch forth your right hand, it will appear as if in the mirror, as if you are stretching forth your left hand. That is the meaning of a lateral inversion. And lastly, the image formed by plane mirror is always factual and upright. That is, the image formed by plane mirror always appear to be at the back of the plane mirror, even though when you look at the back of the mirror, you won't see anything there, but it appears to be at the back of a plane mirror. That is the meaning of factual image. And upright, it will stand upright like the object. Now, let's quickly use one or two of these properties in solving a problem. Our example 2 says, the distance between a man and his image in a plane mirror is 7 meters. If the man moves 1.5 meters away from the mirror, what is the distance between the man and his image? Now, from the question, if the distance between the man and his image is 7 meters, this simply means the man is standing 3.5 meters at the front of a mirror, and which means the image behind the mirror will also be at a 3.5 meter distance. Now, when the man walks 1.5 meter away from the mirror, definitely the image will do the same. It will walk 1.5 meter away from the mirror. And with this, the new distance between the man and the image can be calculated, as we can see here. That is, initially we have a distance between the man and his image as 7. And now the man moved away from the mirror by 1.5 meter, and also the image will move away by 1.5 meter. Adding all this together, we're going to have 10 meter. That is, the new distance between the man and his image in the mirror is now equal to 10 meter. Let's quickly move away from that. Let's see a situation whereby two plane mirrors are inclined at an angle to each other. When two mirrors are inclined at an angle to each other, an observer that is standing before the mirror will see several images, and this can happen when you're at a salon. You can see two mirrors inclined at an angle to each other. So to know the number of images that the observer will see, we can make use of this equation where our n equals to the number of images formed and theta equal to the angle between the two mirrors. And we can also use this equation in solving problem. Let's say in our example 3, an object is placed between two mirrors inclined at an angle 120 to each other. That is, we have two plane mirrors that are inclined at an angle 120 to each other, and an object is placed in between them. So what would be the number of images formed in the mirror? Okay, let's quickly calculate this using the formula. The formula equal to n equal to 360 degree divided by theta minus 1. And if our theta is 120 degree, therefore we are going to have 360 divided by 120, and everything will be, we are going to subtract 1 from everything. That will be 3 minus 1, and we are going to have 2 images. That is when two mirrors are inclined at an angle 120 to each other, the number of image formed will just be 2 in the mirror. That is what this one is telling us. Okay, and lastly, let's consider the effect of rotating a mirror. What would be the effect on the reflected ray? Now, if a mirror is rotated through an angle of theta, as you can see here, this original part of the mirror, and if this mirror is tilted a bit, that is rotated through an angle of theta like this, what will happen to angle of reflection? Definitely, when the mirror is rotated like this, the part of the normal, the original part of the normal will be rotated by theta as well, and it is observed that the reflected ray will be rotated by angle of 2 theta, though that is not proven in this video, but we need to just use the law in solving the problem. But take note of this, that when a mirror is rotated through an angle of theta, a ray of light reflected from this same mirror will be rotated through an angle of 2 theta. Let's see the type of question that we can come across here. Let's consider our last example, which says a ray of light strikes a plane mirror so that the reflected ray makes an angle of 20 degrees with the normal. Now, the mirror is rotated through an angle of 5 degrees. At what angle will the reflected ray be rotated? Now, as we can see from the question, our theta equal to 5 degrees. Now, if a mirror is rotated through an angle of 5 degrees, therefore the reflected ray will be rotated through an angle of 2 multiplied by 5, and that will give us 10 degrees. And with this, we come to the end of this topic. In case you have any question, please you can drop your question in the comment box below, and we'll attend to the question as soon as possible. Thanks for watching.